In my game Blockiverse I create a procedural universe. I changed the algorithm how I create and select living forms for a location. Now I compare the old and new version. The base idea of the old system was to create or load everything at the start of the game. Each plant had a float chance and they were all selected by a random float value. This had the disadvantages that all objects had to be created or loaded at once, which resulted in a long loading time at each start of the game, especially at the first start. Also there were a lot of nested loops in the source code. In the old system there were 4 classes: Spawn Location Data Object, Location Combiner, Dynamic Tree, and Chunk Terrain. Now I go more into detail. Spawn Location Data Objects contained all plants which fit into this specific location, and a method to check if a plant fit into this location. This is a method in detail. The parameters are the location where the plant can grow. The rest is a bitwise check if the plant fit. You can pause the video if you want to read everything. The next class is a Location Combiner. This class contained all possible attributes to describe locations, like vertical indices like ocean, land, etc. Also for biomes and planets. To save performance, a count of plants per planet and per biome was stored. The counts were static since all things had the same count of plants. There was a method to build all possible location attribute combinations. Here you can see all location attributes. And yes, I had to uncomment the different planets, else the loading time would be way too long. Here you can see why. The parameter model container contained all data about possible plants. In the body of the method you can see what I meant with the disadvantage, a lot of nested loops. At the start there were 3 for loops to combine the location attributes. Then the first for loop was to check all plants if they fit into the location. Now to the class Dynamic Tree. This class contained 2 important methods. One selected a previously created spawn location data object, and the other one selected a plant from it. Here you can see how the selection of a location worked. In this method I saved a lot of time by using the previously set count. Since the counts were every time the same, and the list of location was ordered, I was able to increment in the for loop by a higher value than 1, depending on the level in which I searched. If a location was found, the method to select a plant was called. Oh look, another for loop. This method is also the main change in the selection of plants. In the old system, I sum up all chances of all objects and set the plant, if the sum was greater or equal like the plant selection value. The class Chunk Terrain just requested plants for positions. In the new system I will talk about living forms, because I used the old system only for plants, and now I use it also for animals. The same for space objects and planets. The new idea is to create and load living forms only for the current planet. Each living form contains a new long chance, and each set bit in this value stands for a 1.6% chance that this living form can spawn. At the end, living forms are selected by a random bit. This idea removes the disadvantages from the old system. Now there are again 4 important classes: living form and living form biology. In the source code of the game I split them, but if I remove everything, which is not important for this presentation, I can summarize them. Then there are living form cache and the living form creator. Chunk Terrain has the same task like before. A few more things are in other classes. Living forms have chance bits as ulong and a method to set them. This is a method to set the chance bits. At the start I added a shortcut for the 2 cases, which are not affected by random. The cases are if no bit has to be set, and one for all bits. The first case doesn't help so much, but the second one is really important. The normal case is a while loop, which sets bits until the wanted amount of bits is set. Bits are only set and counted if they are not yet set, else you would get 2 less bits. The living form cache does what the name sounds like. It caches loaded or created living forms. This class contains the ID of the space object and all living forms which live there naturally. Also, there is a method to search for a fitting living form. The search of fitting living forms collected first all living forms which have the search chance bit set. If no living form was found, it returns an error value. If more than one was found, it selects one by the noise value. The living form creator contains a list with all cached living forms, methods to handle the cache, and to find or create living forms for a location. In the first step, it's necessary to calculate the chance bit and the noise value. Calculating noise values is not part of this making of. The next method checks if a fitting cache exists. If one was found, it gets the living form from there. Else new living forms are created, and one living form will be returned from there. At the end there are two methods to get a living form. I start with the second method, then it's easier to understand. Like the description of the parameter chance bit says, the method has to return the index of the given living form, if the chance bit is -1, else the index of the living form is searched in the given cache. Remember that this search returns -1 if there was no living form found, else the first method will be confusing. The first method just returns the living form with a fitting index or null, if no living form was found. Chunk.tar has still the same task, request living forms for positions. Other classes where I do something with the handling of living forms are the planet handler. There I check if new living forms have to be created when a player enters a new space object. Somewhere when the world is loaded, the previously stored living forms are loaded into the cache. If there are questions, please write them into the comments. Thank you for watching.